My name is Amalia Thomas, and I'm Product Manager for the FT4 Powder Rheometer.
And I'm Karen O'Grady, and I'm Product Manager for the Morphologi 4.
Today we're going to discuss the combination of particle size and shape measurements together with powder bulk flow behavior.
Yeah, these are really great combination of instruments. So we can look at the bulk powder flow using the FT4, and then we can see on a more size and shape individual particle level using the Morphologi 4.
Particle properties and bulk behavior come hand in hand, but before we discuss how the data from each instrument can be combined, let's have a look at how each individual instrument works and what they measure.
So first we're going to take a look at the Morphologi 4, which is a high-resolution static imaging system. So we can look at size of particles down to less than a micron, and we can use over 20 different morphological properties to fully characterize those powders. It's really important because the size and shape of powders, size and shape of particles can affect how they interact together. So it can affect everything from flow and processability.
That's really interesting because then the size and shape analysis that the Morphologi can do can inform the results of the FT4.
Absolutely. So you might have a powder with similar size distribution, but process completely different. One might block your dye, one might flow fine. And that could be down to the shape of the materials. If you have irregular shaped particles, this can tend to restrict the flow.
So that's where the FT4 comes in. This that I have next to me, this is the FT4 Powder Rheometer. What it does is it measures powder flow properties. It characterizes how powders will behave when they are under processing conditions. The way that it works is by introducing the powder and simulating different amounts of shear and stress and measuring, quantifying how the powder reacts to those processing conditions.
Right, so the FT4 can tell you about the net effect of any differences in size and shape, or it can look at the similarities and show that they're the same.
That's right. So for example, you can have two different powders that have different size and shape. One of them can have larger particles, which tend to flow better, but maybe more regular in shape. And the FT4 can inform you about whether that powder, despite those differences, is still going to be processable or if it's likely to give you issues in the processing line.
So a user can really start to have strategies in place to look at their problems and address them and see the evidence of what's more likely to solve them, whether it's you need to change the particle size and shape properties or change processing.
Correct. One example that comes to mind is around mixing and segregation. Segregation happens when you have a wide particle size distribution, and together on your benchtop, these two instruments can tell you how wide that distribution is with the Morphologi, and the FT4 can then tell you how quickly that segregation is likely to happen before you put that powder in your processing line and it causes blockages and downtime and waste.
So let's look at a pharmaceutical application, which used both these instruments to investigate the differences between two types of granulation processes. Now, granulation is a process that is a way to improve flowability of smaller, more cohesive particles. The two different processes that were looked at are shear granulation and fluidized bed granulation.
This user put the same material through two different types of granulator. With the resulting granules of the shear and fluid bed granulator were put into an FT4 to predict on a benchtop how they are likely to behave. The FT4, with each of these samples of granules, measured the resistance to flow as the total energy necessary to make it move in a very specific path. And what the results show, here in this graph, the blue line represents the shear granulator granules and the red line represents the granules from the fluid bed granulator. What the FT4 told us is that the shear granulator produced granules that would be harder to process and move further down the production line.
So what's interesting is when we looked at the two different granules using the Morphologi 4, we saw that the shear granulated particles had a more circularity in shape. We know that more spherical particles are better at flowing, but in this case it reflected that those shear granulated particles had a more compact structure of the particles in the granule, which was formed during the granulation process. And that makes the granules harder to move as a bulk and increases the energy required to flow. But also, those shear granules showed a broader distribution, which tends to mean more complex packing, and those smaller particles jam up the larger particles, which adds resistance to flow.
So that's a great example of how the two instruments can work together. For this particular case study, the FT4 was able to inform which of the two granulators was more likely to provide successful materials, and the Morphologi was able to explain why that was the more appropriate material.
Absolutely. So by using both of these products, you get a complete picture of how size and shape and processability are related. So the users can have more informed decisions about their formulation and processing.
If you want to learn more about the FT4 Powder Rheometer or the Morphologi 4 can help you understand your materials better, please refer to the Analytical website.